Hello friends, welcome to CSAT Mantra, CSAT made easy and affordable. Welcome to our daily dose of solved questions. For more solved questions and concepts, kindly join our Telegram channel. To enroll in our course, kindly visit csatmantra.com. Both the links are given below in the description. The remainder when 3 power 21 is divided by 5 is. This is a practice question from number system chapter based on remainder theorem. Most of you had confusion in this problem, so I thought of providing a video solution. Now let's go through the basics. We have two types of remainder theorem. One which involves addition or subtraction, another which involves multiplication. This is the first type of remainder theorem. Remainder of a plus or minus b plus or minus c plus or minus and so on when divided by divisor d, that is equal to remainder of a when divided by d plus or minus whatever the sign you have here, you will be having the same sign here, my friends. Okay, if you have plus here, you will be having plus here. If you have minus here, you will be having minus here. Both signs should be same. Remainder of b divided by d, this is how you read it. Okay, remainder, this bracket is of b divided by small d plus or minus remainder of c divided by small d plus or minus so on. Now let's see how we got this. Remainder of 6 plus 7 when divided by 5. This is left hand side of this equation, my friends. 6 plus 7 is 13. Okay, 13 when divided by 5. What is the remainder? 3, my friends. Okay, 13 is equal 5 into 2 plus 3. Remainder is 3. So on the left hand side we got the remainder as 3. Now let's see on the right hand side. This is equal to remainder of 6 by 5 plus remainder of 7 by 5. Remainder of 6 by 5, that is 1. Remainder of 7 by 5, that is 2. 1 plus 2, that is 3. So on the left hand side we got the remainder 3. On the right hand side we got the remainder 3. Both are equal. This is how this result came, my friends. The people who have came before us, they have paid attention to this kind of pattern. And from that they have deduced this result. That's it, nothing more. Now pay attention here. If this is given, I can add them like this and find out the remainder. If this is given, I can split them like this and find out the remainder. Both will be same, my friends. Now this is second type of remainder theorem. Remainder of a into b into c, multiplication involved here, when divided by divisor d, that is equal to remainder of a when divided by d into remainder of b when divided by d into remainder of c when divided by d and so on. Now see, we have remainder of 6 into 7 when divided by 5. Left hand side, 6 into 7, that is 42 when divided by 5. Okay, what is the remainder when 42 divided by 5? The remainder is 2, my friends. Okay, 42. 5 8s are 40, remainder is 2. So on left hand side we have the remainder 2. Let's check on the right hand side. Okay, remainder 6 divided by 5 into remainder 7 divided by 5. What is remainder when 6 divided by 5? That is 1. Okay, 6 is equal 5 into 1 plus 1, my friends. Okay, remainder is 1. When 7 divided by 5, remainder is 2. Okay, 7 is equal 5 into 1 plus 2, remainder is 2. So 1 into 2 is 2. So left hand side is equal to right hand side. So this theorem satisfies. This is what people have paid attention to, this kind of pattern, and they have deduced this result, my friends. Now what are the possible remainders when a number is divided by 5? We can have the remainder is 0 when that number is perfectly divisible by 5. We can have the remainder 1, 2, 3, 4. These are the possible remainders when a number is divided by 5. We have seen this in remainders lecture, my friends. If the remainder is coming as 5, then you divide this 5 with 5 again. Remainder is 0. If the remainder is coming as 6, okay, you divide this 6 with 5, the remainder is 1. So these are the possible remainders when a number is divided by 5. Now when minus 9 when divided by 5, I am telling minus 9 when divided by 5, this is dividend, this is divisor. This is possible, right? We do have such kind of fractions, such kind of numbers in mathematics. Okay, so minus 9 is equal to 5 is the divisor, minus 1 minus 4. 5 into minus 1 is minus 5, minus 4. Okay, this is minus 9. Left hand side minus 9, right hand side minus 9. Both are equal. Now tell me, isn't this equation mathematically correct? This equation is mathematically correct, my friends. Okay, here the dividend is minus 9, divisor is 5, quotient is minus 1, remainder is minus 4. If you see, divisor is negative here, quotient is negative, remainder also negative. I am rewriting this minus 9 by 5 as 9 divided by minus 5. So 9 is the dividend here, divisor minus 5. Whereas here minus 9 is the dividend and 5 is the divisor. Now see, 9 is equal to minus 5 minus 1 plus 4. Minus 5 into minus 1, that is 5, plus 4, that is 9. Left hand side, right hand side, both are equal. Now see, in this equation, divisor is positive, my friends. Now in this equation, dividend is positive, divisor is negative minus 5, quotient is negative, remainder is positive. Both the equations are mathematically correct. So what I am trying to tell you from this example is, dividend can be positive or negative, divisor can be positive or negative, quotient can be positive or negative. If it is 9 by 5, then we will be having quotient as positive, my friends. Okay, 9 is equal 5 into 1 plus 4. Okay, quotient is positive. So quotient can be positive or negative, remainder can be positive or negative. Mathematically you can have them positive or negative, my friends. Nothing wrong with it. In fact, taking negative remainders will make our lives easier. You will see it in this problem. But generally, officially, when you talk about remainders, you will be talking in terms of positive remainders. These are positive remainders, right? But in the options, if negative remainders are also there, you can mark them. Nothing wrong with it. So what are the possible negative remainders 5 can have when a number is divided by 5? Minus 1 you can have, minus 2, minus 3, minus 4. Okay, just like the positive remainders. 0 cannot be negative or positive. Okay, there is only one 0. So the takeaway from here is, dividend can be positive or negative, divisor can be positive or negative, quotient can be positive or negative, remainder can be positive or negative. When we talk about remainders officially, we talk in terms of positive remainders. But in options, if there is negative remainder, you can mark them safely, my friends. Okay, nothing wrong with it when it comes to mathematics. Mathematically, they are all correct. Now tell me, what is the remainder when 9 divided by 5? 9 is equal 5 into 1 plus 4. So 4 is the remainder. 4 is the positive remainder, my friends. If I say what is the negative remainder, then you will be writing 9 as 5 into 2 minus 1. 5 into 2 is 10 minus 1. This is 9. Okay, 9 is equal to 9. So here minus 1 is the remainder. It is negative remainder, my friends. So this and this both are possible remainders, my friends. Mathematically correct. This is positive remainder. This is negative remainder. What is 9 by 5? Okay, 3 square by 5, right? Now 3 power 21 when divided by 5. 3 power 21 I am writing like this. Rather than writing like this, the questioner has written like this, my friends. Okay, nothing wrong, right? So 3 power 21 when divided by 5, remainder, that is the equal to remainder of 3 by 5 into remainder of 3 by 5, remainder of 3 by 5, 21 times, my friends. Okay, this is what we learnt in type 2 remainder theorem, right? Now most of the people have problem here. What is the remainder when 3 divided by 5? See, you are dividing 3 with 5. See, 5 ones are 5. But here you have 3. So you cannot have 1 as quotient. So 5 0. 0. Remainder 3, my friends. So you are writing 3 as 5 into 0 plus 3. Okay, remainder. This is how you write, right? This is 5. 5 into 0 is 0 plus 3. Okay. So 3 is equal 3. So what is the remainder when 3 divided by 5? Remainder is 3, my friends. What is the remainder when 4 divided by 5? Remainder is 4, my friends. 4 is equal 5 into 0 plus 4. Remainder is 4. What is the remainder when 2 divided by 5? Okay, 2 you can write as 5 into 0 plus 2. So the remainder is 2. 0 is the quotient. 5 is the divisor. 2 is the dividend. What is the remainder when 1 divided by 5? Okay, 1 is equal 5 into 0 plus 1, remainder is 1. What is the remainder when 0 divided by 5? 0, you can write it as 5 into 0 plus 0, remainder is 0, quotient is 0, dividend is 0. What is the remainder when 5 divided by 5? You are writing 5 as 5 into 1 plus 0. Okay, so the remainder is 0, 5 is exactly divisible by 5. What is the remainder when 6 divided by 5? 6 is equal 5 into 1 plus 1, remainder is 1, quotient is 1, divisor is 5. Very simple thing, my friends. Okay, you have learned this in school. So any number which is less than 5, that will be your remainder, my friends. Okay, 3 when you divide it with 5, the remainder will be 3. 4 when you divide it with 5, the remainder will be 4. 5 when you divide it with 5, remainder will be 0. Now see, you are dividing 3 power 21 with 5. Let's say you got the quotient as x for the first time. Some number you would subtract. Second time you would be having the quotient. Okay, you subtract. You will be continuing this. I'm telling you, continuing. You would be again and again dividing it with 5 till you get the remainder less than 5, my friends. What is the maximum remainder when a number is divided by 5? 4, right? You can have 0, 1, 2, 3, 4. I am talking about the positive remainders, okay? So, this is the maximum remainder when a number is divided by 5. So, till you get these remainders, you would be continuing this process, my friends. This is what we have learnt in our school days, right? Now, see, you are having here remainder 3, here also remainder 3, here also remainder 3, 21 times. The problem has not simplified at all, my friends. Again, you are getting 3 power 21. This is greater than 4. Again, you have to divide it with 5 and find out the remainder. So, the problem has not simplified at all. Now, rather than writing like this, I have written the same thing like this in terms of 3 square. 3 square into 3 square 10 times. How many 3 powers you will be having? 20, my friends. Okay, 2 into 10, 20. So, here power 1. So, total 21. Power will be 21 when divided by 5. Now again, remainder theorem formula, remainder of 3 square when divided by 5, remainder of 3 square when divided by 5, 10 times, okay, 3 power 20, now you will be having one more 3, so remainder of 3 when divided by 5. Now, what is the positive remainder when 3 square divided by 5? We have seen this, okay, 3 square is 9, 9 by 5, what is the positive remainder? 4, my friends. So, 4 into 4 up to 10 times, here you will be having the remainder 3. Is this problem simplified? Somewhat simplified, but again, not to the extent we want, my friends. Again, it's a big problem. Now, what if I take the negative remainder? What is the negative remainder when 3 square divided by 5? 9 divided by 5, that is minus 1, my friends. We have seen this. 9 is equal 5 into 2 minus 1. Mathematically correct. So, minus 1 into minus 1 up to 10 times. Okay, here you will be having 3. This is a minus 1 power 10 into 3. Minus 1 power 10 is okay, 1 into 3. So 1 into 3 is 3. So the remainder is 3, which is less than 4, my friends. Less than or equal to 4. So our answer is C. Now see here the beauty of negative remainders. It has simplified the problem like anything. If you solve this problem using positive remainders, it will take more than a day for you. But if you solve it using negative remainders, you can solve this problem within 5 seconds, my friends. Now see, I am writing the same thing like this. Remainder of 3 square whole power 10. 10 times into 3 divided by 5. This is remainder of 3 square by 5. 10 times, right? That means power 10 into remainder of 3 by 5. What do you mean by 10 times, my friends? Power 10, right? This is what I did here. See here you have written so many terms. Here just, okay, 1 or 2 terms. That's what I am saying. You can solve this problem within 5 seconds. Now remainder of 3 square when divided by 5. Negative remainder. What is that? Minus 1 power 10 into remainder of 3 when divided by 5. That is 3. So this is 1 into 3. This is 3. So our answer is C. Now say you want to take the positive remainders only. Here the problem is not simplified. Here the problem is not simplified because here the remainder is plus 3. Here the remainder is plus 4. Now you want to go power 3 cube. So 3 cube divided by 5. What is the remainder? 27 by 5. The remainder is 2. Again, problem is not simplified. Now you go for one more power. Okay, 3 power 4 divided by 5. What is 3 power 4? Okay, 81. 81 divided by 5, the remainder is plus 1. Yes, the problem is simplified. See, the thing here is you can definitely solve this problem using positive remainders. At that time, you have to go till 3 power 4. When it comes to negative remainders, you can solve this problem by going till 3 square only. This makes our life easier. So that's why I want you to learn this negative remainders concept. Nothing difficult, my friends, very easy. Now let's solve this by writing in terms of 3 power 4. 3 power 21, I am writing it as 3 power 4 whole power 5. 4 5s are 20. 1 3 is left when divided by 5. So remainder 3 power 4 when divided by 5 whole power 5 into remainder 3 when divided by 5. So here we will be having remainder 1 plus 1. Here 3, 1 into 3 is 3. So our answer is C. But I don't want to go till 3 power 4. I am lazy. I will go till 3 square only. Here it is 3 power 4, my friends. For some other numbers it can be 6 power 7. You have to go till 6 power 7. This is not the wise thing to do. So consider the negative remainders. That will make your life easier. Now this is one aspect of this problem, taking negative remainders. Now see, this problem will not be simplified at all if you have remainders other than plus 1 or minus 1, my friends. See, here we have remainder plus 2, not simplified. Here we have remainder plus 3, not simplified. Here we have remainder plus 4, not simplified. When it comes to remainder minus 1, remainder plus 1, the problem has been simplified like anything. So the funda here is you have to look for the remainders plus 1 or minus 1 always. The problem will be given in such a way that no matter, it will definitely have plus 1 or minus remainders at some point, my friends. You have to find out at which power of 3 you are having the remainder as plus 1 or minus 1 when divided by the divisor. So always look for the remainders plus 1 or minus 1. So at which power of numerator when divided by the denominator you are having the remainder as plus 1 or minus 1. This is the funda in this problem. Problem cannot be any other way. Definitely you will be having the plus 1 or minus 1. Now you may say, sir, does the plus 1 or minus 1 remainders occur for every number? Yes, my friends, because there is a thing called cyclicity of remainders. See, when 3 divided by 5, remainder is 3. 3 square divided by 5, remainder is 4. 3 cube divided by 5, remainder is 2. 3 power 4 divided by 5, remainder is 1. Now 3 power 5 divided by 5, remainder is 3. Because you can write it as 3 power 4 by 5 into 3 by 5, right? Remainder theorem. What is the remainder of 3 power 4 when divided by 5? 1. This is 3. So this is 3. Now see, after 4th power, again you are getting the remainder 3, my friends. You got this remainder when 3 is divided by 5. Now pay attention here. 3 is not divisible by 5, so you wouldn't be having the 0 remainders. Now what are other positive remainders when a number is divided by 5? 1, 2, 3, 4, my friends. All remainders covered, right? So when all remainders covered, again you would be starting with the first, my friends. This is called cyclicity. So 3 power n by 5. What is the cyclicity? Cyclicity is 4, my friends. After 4th power, you would be again having the same remainder. Now don't get into this cyclicity of remainders. This is not needed for us. All I am saying is any power of 3 you take, at some point of time you will be having plus 1 as remainder, my friends. This is same with every other number. You take 12 power n when divided by 7. At some point of time, after some n, you will be having plus 1 as your remainder, my friends. This is for sure. So rather than going in terms of positive remainders that may occur at n is equal to 6 or 7, if you go in terms of negative remainders which may occur at n is equal to 1 or 2, then you would be simplifying this problem like anything, my friends. So for any number you would be having plus 1 or minus 1 as remainders. You just have to see at which point you are getting plus 1 or minus 1 as your remainder, and you have to choose that one, the one which will make your life easier. Now pause this video and solve this problem. You can solve this problem in 5 to 10 seconds, my friends. Okay, remainder when 2 power 99 divided by 33. Now I said always look for which power of 2 when divided by 33 is giving us plus 1 or minus 1 as remainders. See, 2 power 1 when divided by 33, the remainder is plus 2. This is not going to be helpful. 2 square, okay, plus 4. 2 cube plus 8 is the remainder. 2 power 4, remainder is plus 16. 2 power 5. 2 power 5 is 32, my friends, okay, 32. So 32 when divided by 33, I am having the remainder as minus 1. Okay, this is 33 minus 1, right? This is equal 32. So here the remainder is minus 1. We are getting minus 1 remainder for 2 power 5, my friends. So you are writing this as 2 power 5, 19, 2 power 4 by 33. Okay, see, 99 when divided by 5. 5 into 19 plus 4. 19 times 5 are 19 times 5. Remainder is 4. When divided by 33, okay, this is remainder 2 power 5 by 33 whole power 19 times, my friends. Okay, you can take this power outside. This is what we have seen in the previous problem, into remainder when 2 power 4 divided by 33. So what is the remainder here? Minus 1 power 19 here plus 16. Now this is minus 1 into 16, this is minus 16. But here the remainders are given in terms of positive. So you have to divide this remainder till you get the required remainder, right? So I am again dividing this minus 16 with 33. 33 minus 1s are plus 17. So our answer is D. This is one way of writing minus 16, my friends, and getting the remainder. If it is too confusing, then you can add 33 to this negative remainder, my friends. So you are getting 17 here. This is same as, see, I brought this minus 33 this side. Okay, this is equal 17. This is what I did here. So when you are getting the negative remainder, all you do is just add the divisor and find out the positive remainder, my friends. So our answer is D. See, it took around 25 minutes to explain this, but you can definitely solve these kind of problems in 5 to 10 seconds, my friends. So always you have to look for which power of 2 numerator is giving you the remainder plus 1 or minus 1, and then simplify the problem, my friends. Clear, right? Now I request you to solve these kind of similar problems which we have given in a remainders lecture. Try to see if you are getting the answers, okay, as quick as possible. You can pick up any problem from anywhere, my friends. You can solve them in 5 to 10 seconds. Thank you.